Assalamu alaikum wa rahmatullahi wa barakatuh. In this lesson, we are going to talk about a new integration which is called integration by substitution. Sometimes we call it integration by changing the variables, which means we change what's given to us like x variable to another variable called u or t or whatever. But to start such integration, we need to know what's the key of solving such integrations. The key for integrations by substitution is to make sure that the integral has a function and its derivative. But the problem is difficult sometimes to recognize the integral has a function and its derivative or not. Sometimes the derivative is not shown clearly. Sometimes we don't know what is the function to search for its derivative. So we will divide the lesson into two parts. The first part is how to recognize that the integration can be done by substitution or not. And the second part is what's the method or what are the methods or steps of evaluating integrals by substitution. Let us start with the first idea is how to recognize, how to know this integration or that integration or any integration can be done by substitution or not. To make this idea easy, we should remember some patterns or some functions. So here, to understand, we need to have some idea about patterns, recognitions, which means we need to memorize some shapes of integration by substitution. The first shape, as we said, here is to make sure that we have a function raised to power. Function, as we can see here, function raised to power. We have a function and raised to power like n. And of course, multiplied by its derivative. In some cases, this power is not given to you clearly. This power is given to you down. So also here, in the denominator, it's integration by substitution, and we need to make sure that the derivative also is given to us. Sometimes the function is under a radical, which means also integration by substitution, because this means the power, and also the derivative is given to us. In some other cases, the radical is in the denominator. This is also a kind of function raised to power. So once we see these examples, like here, we can easily understand that integration by substitution done or not done. Look at here the first example, x or function raised to power. If we look at this example, we can easily see there is a function here, or bracket, raised to power 2. And at the same time, the derivative is given to us, which is 2x. So we can easily say, yes, this is integration by substitution. Also here, we can see there is sine x raised to power 4. And the derivative of the sine is given to us, which is cosine. That means sine x here is the function that we are looking for. The second example here sometimes is difficult to be recognized, because sine to the power 4, it means sine x all to the power 4. So we should make sure that we take the sine without the power as the function. The second case, when we have radical raised to power, so in this case, if you look at this example, we can easily say that there is function inside the radical and its derivative is also given to us. So we can easily say that this integration by substitution. Also, as we said here, sometimes the radical is in the denominator, and we can see that this is the function which is inside the radical, and the derivative of 2x squared is given to us, which is 4x. If we take this example, here we can see also that there is function in the denominator raised to power 2, and the derivative of this function is minus 4x, which is also given to us. The last example here, for these four cases, we have 5 plus sine x raised to power 2, but in the denominator, and the derivative of 5 is 0, but the derivative of sine is cosine, which is also given to us. We can have many examples like this one. Okay, this example can be done also by integration by substitution. Now let's go to the second case. The second case here is when we have exponential function, but the exponent or the power is another function, not x, multiplied by the derivative of this exponent. For example, here I have exponential raised to power x squared minus 5. We need to make sure, do we have the derivative of x squared? Yes, it is 2x. So yes, this one, integration by substitution. Another example, we have exponential raised to power sine. Do you have the derivative of the sine? Yes. That means, yes, this one, integration by substitution. Let's look at these examples. Here, when we have denominator down, which is the case of having only denominator without raising to power. So here, a special case when the denominator or the function in the denominator is not raised to power. It's alone. This is what we call it the logarithmic rule. So in this case, we don't look at the raised to power. We look at the function itself completely. So the function here is not raised to power. It is 7 plus 2x to the power 3. The derivative here is 6x squared, but we have only x squared. Yes, it's accepted because 6 is missing. We can write it later. Also here we have function in the denominator and its derivative available up. And the last example, we have function. So you need to make sure here that when we have function only, not function raised to power, this is we call it logarithmic rule. Logarithmic rule. The common case is about function or trigonometric function, raised, a trigonometric function with function not x. So when we have, for example, sine of x multiplied by the derivative of x, such as this example, when I have sine 1 minus x squared and the derivative of the inside of the trigonometric is given, we can use integration by substitution. When we have, for example, secant squared, we know it is the integral of secant squared is tan, but instead of f of x, here we should have the derivative of f of x. For example, when I have secant squared of ln of x, we need to make sure, is the derivative of ln is given to us? Yes. So this integration by substitution. Cosine, the same idea, and secant tan is the same idea. So, and cosecant cotan, the same idea. We need to make sure that the derivative is given to us. Now let's go to more ideas about integration by substitution, which is when we have integrals lead to inverse trigonometric functions. First, we need to recall the shapes of integrals that lead to inverse trigonometric function. We need to remember that when we have integration of 1 over 1 plus x squared, easily we know it is arctan or tan inverse. But here, if we change the x to be function, so in this case, also we can say it is integration by substitution, but we need to make sure that the derivative of this function is provided. Also, for example, we can see here sine to the power 2 multiplied to plus 1 multiplied by the cosine. So this is integration by substitution. Also here we know that this one will give me arc sine or sine inverse. But instead of x, if I have another function, but I need to make sure that I have also the derivative of this function, so yes, we can say it is integration by substitution. For example, when we have square root of 1 minus tan, we need to make sure the derivative of tan is given to us. So yes, it is integration by substitution, because the derivative of tan is secant squared. The last example maybe in this part is when we have integration leads to arc secant. But if I have something else but not x, it's another function, I need to make sure that the derivative of this function is given to us. For example, when I have here the function is x to the power 5, it's written here twice, and I have its derivative, which is 5x to the power 4, so we can say this is integration by substitution. So we need to memorize all these cases, and there are many other cases, but these are the main cases of integration by substitution. Now let us go to a new idea. After recognizing integration by substitution, what should I do? I need to change the variable, which means we need to change the set of things, which is the function that we mentioned here. It's the function. We need to change it to another letter, another variable called u, for example, or t. So usually here, when I have these examples, I need to change set of things, not x only, with a new variable called u, for example. So I can see here, I have function raised to power 4. That means what's inside this bracket, that we call it function, is u. So u here is 3x minus 1. Look at this example, the coming example here. We don't have function raised to power. So we will consider it as raised to power 1. Do we have the derivative? Yes, 2x plus 1. So what's inside, it is u. So here u, I mean, it's x squared plus x. Let's go to another example. When we have radical or square root here, what's inside the square root, that we call it f, here it will be u. And we need to make sure that the derivative is given to us. When we have function down here, but here the function is not raised to any power, which means we will consider it as logarithmic rule. If I have the derivative for all of the integral, which is minus 4x, which is given to us, so yes, u is what's the denominator. The last question here, we have cosine square and sine. We can see here clearly that the cosine is raised to power, so that means u is the cosine x. Now, the last example here, as we can see, there is function in the denominator raised to power 3, but in the numerator we don't have the derivative. So sometimes some people, they say this is not integration by substitution. In fact, it is integration by substitution. First, because this function is raised to power. Second, because the derivative here is a 3x squared plus 3 that we don't have in the numerator. But if I multiply this one by 3 only, I get the same derivative. But we cannot multiply arbitrarily by this way. You should divide also by 1/3. So this technique, we will do it later. This technique is when we don't have exactly the derivative, we have part of the derivative. We have the derivative partially. This is also integration by substitution. So what's inside is the u. Now we have learned how to know integration by substitution and which part should be changed to be another variable u. Now let's talk about the steps of evaluating integration by substitution. The steps here are, the first step, we need to determine u. What's u? As we just explained. And since we are going to change all integrations or all variables, even dx, so you should find also dx. And to find dx, we need first to find the derivative of u, which is du over dx. Also, after that, we need to rewrite all of the integrals, everything in the integral, to be in terms of another variable. Even the boundaries, also we need to change them from in terms of x to be in terms of u. Then after that, we should get back the new integration to be in terms of u. Then we should get back the integral to be again in terms of x. Now let us take this example here. First, I need to recognize, is this integration by substitution? Let me see. There is function here. Yes. Raised to power. So yes, raised to power. Do you have the derivative? Yes, the derivative is 2x. So yes, we can say this integration by substitution. So what's the first step? I need to know what's u. U is what's the inside the bracket or what's under the square. So u is x squared plus 1. So the next step, I need to find the derivative. So the derivative of u is 2x. But why should I find the derivative? Because I have in the integration dx. And I need to change this dx. So I need to find what dx is. So dx here, just we need to move this one to the other side and bring 2x down. So it will be dx equals du over 2x. So now we are going to change everything to be in terms of x. So this one here will be, of course, u raised to power 2. 2x, I don't deal with it at this moment. I keep it as it is. But dx here, I should write du over 2x. So I got this integration, but still I have two variables. But I can easily cancel 2x with 2x to get the new integration. So again, when we have this integration, first we need to change the dx. After changing the dx, I cancel 2x with 2x. Then after canceling 2x with 2x, I will get a new integration which has only u. Then I do the integration of u squared to be u to the power 3 over 3. Let us take more examples. And before taking more examples, we need to make sure that we get back the original integral. One more example to understand is we have 5 cosine 5x. Here maybe it's difficult to recognize the integral because we have only cosine. But we need to remember the trigonometrics. What angle here is u. So u here is only 5x. So we need also to find the derivative, which is only 5. Then we need to find dx, which is du over 5. Then we need to rewrite everything to be in terms of u. So we can easily say this is 5 here, and we have cosine u by du over 5. Then we cancel 5 with 5. Then we get integral only cosine. Then after getting integral of cosine, we know the integral of cosine is sine u plus c. One more example, which one we have only function raised to power, but unfortunately we don't have any derivative. In fact, the derivative is given to us, but it's hidden, because the derivative of x plus 2 is 1, and 1 is not given to us, but we can easily know it is hidden here, 1. Now, u is what's inside the bracket, x plus 2. The derivative is 1. So in this case, we rewrite du is dx over 1, or dx is du over 1. So then we change the variable x plus 2 to be u to the power 5, and dx will be du. Then we evaluate to be u to the power 6 over 6. Then we get back the integration to be in terms of the original variable, which is x. So we remove u and you put x plus 2. One more example, but in this example, we have boundaries. So we need to make sure that even the boundaries should be changed. First, we should not recognize that there is a function and its derivative. In fact, here we have sine squared. It means sine to the power 2. So do we have the derivative of sine x? Yes, we have the derivative of sine x, which is what? Cosine x. So yes, this one is integration by substitution. Integration by substitution. So to start with, we should also make sure that we have always function and its derivative. We should find first u. So u, as we just mentioned, u is the inside the function, which is sine x, and we need to find du over dx, which is cosine x. Now we want to change everything to be in terms of u, and to change everything to be in terms of u, we find dx equals du over cosine. Why we find this one? Because in the integration also we have dx. Now we change everything to be in terms of u. To substitute sine square x by cosine x, we will change everything to be in terms of u. First, we remove the sign. What we put? We put, of course, u. So in this case, we put u, so it will be u squared. Or what about cosine? We cannot do anything for it, but if I remove this dx and I put du over cosine x, so I can easily say I can cancel cosine x with cosine x, so I will get only u squared du. Then I do the integration, but here we need to make sure that the original integration or the original boundaries are in terms of x. So 0 to pi over 2 are related to x, not to u. So this also should be changed. So we need to rewrite also the upper and the lower to be in terms of u, because what's given to us is in terms of x. So here we change them to be in terms of x, in terms of u. To do that, we know that u is sine x. So that means u is sine pi over 2, so it will be 1, and u is sine 0 will be 0. So the new integration will be sine from 0 to 1. And here we don't need to get back the integration. Directly we integrate u to the power 3 over 3. Then we replace 0 and 1. I don't need to get back the variable x. So after evaluating, we need to replace up minus replacing down. So it will be 1 over 3 minus 0, which is 1 over 3. We can take many examples, but we need to go a little bit faster than before. So if I take this example, also I need to find the function and its derivative, and the function clearly is given to me, and the derivative is also given to me. So we need to know which one is the u, and the u here is what's inside the radical. So u is 5x to the power 3. Then I find du over dx. Then I find dx. Then I replace everything to be in terms of u. So I will get directly this one to be u and this one to be du, but still I have 0 to 1, so I need also to change 0 and 1 to be in terms of u, and here after changing them it will be 5 multiplied by 1 to the power 3 plus 4, it will be 9, and we get this integration. Now the last example we need to solve to understand the lesson. When we have, as we mentioned before, when we have function but its derivative is not given to us completely, something missing. So here, first I need to recognize, is this integration by substitution? Do we have one of the cases? Here, the case is function raised to power in the denominator. So yes, it is integration by substitution. Now, what's u? U is what's the inside the bracket, what's under the power. So u here is exactly x cubed plus 3x minus 5. So I found u. Then the next step, to change everything, I have dx, and to get dx I need to find the derivative, which is du over dx. So the du over dx is a 3x squared plus 3. I need dx, so what should I do to get dx? I move dx out and I put this quantity in the denominator instead of dx. So I get dx equals du over 3x squared plus. Why I get this one? Why I find this one? Because I have in the original integration I have dx. Now let's change all variables. I have this integration, the original one. I need to change dx, and I need to change this one as u. So what I will get? I will get this one will be changed to be u, so it will be u cubed. X squared plus 1, there is nothing to change at this moment. Then this dx will be what? Will be du over 3x squared plus 3. Now so far, still I have, unfortunately, two variables. I still have x squared plus 3, and I have u. We cannot continue, we cannot proceed unless we change everything to be in terms of u. So how can I deal with these two things? Here, either I multiply by 3, then I divide by 3, then I cancel, but it's easy for me to find the common denominator here, the common factor, So we get here 3 outside, we get x squared plus 1. If I do this, I can easily cancel later. So when I get the common factor, I can easily cancel x squared plus 1 with x squared plus 1. So then I get a new integration with only u. Now the integration in terms of only u, I can solve it easily, but I need just to rearrange the information. I need to take this 3 outside, and at the same time I need to take this u to the power 3 up to make it normal integration. So after doing that, I get an integration that's easy to be done, which is u to the power minus 3 plus 1 over minus 3 plus 1 over minus 3 plus 1. So I get a new integration, which is u to the power minus 2 over minus 2. But this integration is in terms of u. We need to get back the original variable, which is x cubed plus 3x minus 5. So we return to the original integration by this way. Just remove u and put what was its variable. And thank you very much for being patient, because it's long video, and I hope you understand these examples and this lesson. Thank you very much.